Welcome to this deep dive into the world of software architecture. We've got some fascinating excerpts from Fundamentals of Software Architecture by Mark Richards and Neil Ford. It feels like we're getting a sneak peek into how the experts think.
It is. And what's really cool about this book is how it focuses on an engineering approach, moving away from software development as just a craft and more toward a disciplined, repeatable process.
Oh, interesting. So less like artistic inspiration and more like building a bridge with like established principles and methods.
Precisely. And that's super important. You see, the authors actually point out that the software development industry is relatively young compared to other engineering disciplines.
I guess that makes sense.
So we can learn a lot from their established processes. I mean, you wouldn't build a skyscraper without blueprints and calculations, right?
No way. But software, it changes so quickly. How do you engineer something that's constantly evolving?
That's a great question. And the book actually acknowledges that right up front. The definition of software architecture itself is always shifting, thanks to new technologies and approaches. Just look at the impact of microservices.
Yeah, true.
They even say that software architecture is a constantly moving target.
Okay, yeah, that makes sense.
Yeah.
A cathedral and a spaceship need different blueprints.
Mm-hmm.
So let's get specific. What do these experts say are the core responsibilities of a software architect?
Well, they list out 8 core responsibilities, and it's not all about being a coding whiz.
Oh.
While those technical skills are essential, they really emphasize soft skills too, like communication and negotiation.
Interesting. Why are those soft skills so crucial for an architect?
Okay, so imagine you're an architect proposing a new design. You have to effectively communicate that vision, right?
Yeah.
But not just to other techies. You've got CEOs, developers, project managers, all different audiences.
So architects need to be able to speak different languages, translating between the technical and the business side of things.
Exactly. They're kind of like diplomats, building bridges between these different worlds.
Right.
The book even calls architects the keeper of the big picture. They have to understand how all the pieces fit together, making sure the technical decisions actually align with the overall business goals.
That makes a lot of sense. It's not just about building software that works. It's about building software that solves the right problems in the right way.
Right. And a big part of that is analyzing trade-offs. Every decision has consequences, and a good architect has to understand those consequences and make informed choices.
Can you give me an example of a trade-off that an architect might face?
Absolutely. Let's say you're designing an auction system and you're trying to decide whether to use a message topic or a queue for handling bids.
Okay.
A topic lets multiple subscribers get those messages, offering greater flexibility and extensibility.
So flexibility is usually a good thing. Yeah.
It is, but here's the trade-off. With a topic, anyone who subscribes can potentially get their hands on that bid data. Yeah, and that could be a security risk. Queues, on the other hand, offer more control over who actually receives those messages, making things more secure.
Ah, I see. So what's good for flexibility might be bad for security, and the architect has to weigh those factors.
Exactly. And that's why the book emphasizes understanding those architectural characteristics, what they often call the inamilities, like scalability, reliability, and maintainability.
Oh, yeah, the inamilities. We hear about those all the time.
Yeah.
But how do they play into architectural decisions?
They're like the system's non-functional requirements, the qualities beyond the basic functionality.
Okay.
Think of it like this. You can build a car that runs, right?
Sure.
But is it fuel efficient? Is it safe in a crash? Is it easy to repair? These are its inamilities, and they're crucial.
Okay, that's a great analogy. So how does an architect figure out which inamilities are most important for a particular system?
It all boils down to the business requirements. They drive everything. They use a case study called silicon sandwiches to illustrate this.
Silicon sandwiches. Like a tech company cafeteria?
Well, no, it's an online sandwich shop, actually.
Oh, okay. Though I'm more interested in the software side of things.
Oh, of course. The case study highlights how business needs like mobile accessibility and customization options get translated into specific capabilities.
Okay.
For instance, if you've got a lot of mobile users, performance and responsiveness suddenly becomes super important.
So the architect has to analyze those business needs and figure out which technical qualities support them.
Exactly. They're like a translator, turning business goals into technical blueprints. And to make sure those decisions are documented and understood, they use architecture decision records, or ADRs.
ADRs. What are those?
Think of them as a logbook for important decisions. They capture not just what was decided, but why.
Gotcha.
Like if you chose to use a message queue instead of a topic for handling bids, the ADR would explain why. Security concerns, what other options you considered, and what you expect the consequences to be.
So it's like a trail of breadcrumbs showing how you got to a specific design.
Exactly. It's all about transparency and accountability. It also helps with future decisions because it documents the reasoning behind past choices.
Okay, this is all making sense. We've talked about the what and the why of software architecture. Let's get to the how. The book covers all sorts of different approaches, from monolithic to microservices. Where do we even begin?
Well, they spend quite a bit of time comparing monolithic and distributed architectures. It's a fundamental decision. But before diving into those, they introduce this idea of an architecture quantum.
Quantum, like in physics.
Well, it's an analogy, but a powerful one. An architecture quantum represents a bunch of components that share the same architectural characteristics.
Okay.
They have to be deployed and scaled together. They basically form an independent unit within the whole system.
So if different parts of my system have really different needs, like one needs to be super secure and another needs to be ultra scalable, I might need multiple quanta.
Exactly. And that naturally leads you toward a distributed architecture, where different parts of the system are deployed and managed separately. Monolithic architectures, on the other hand, package everything together into a single unit.
So monolithic is like a tightly integrated machine, while distributed is more like a collection of interconnected modules.
That's a great way to put it. Each approach has its own pros and cons. Monoliths can be simpler to develop and deploy at first, but as the system grows, they tend to become less flexible and harder to scale.
And distributed systems give you more flexibility and scalability, but come with all those complexities of communication and coordination between modules.
Precisely. And that's where, again, understanding those suitabilities is crucial. You have to think about those trade-offs and pick the architecture that best fits your specific needs and constraints.
It's about finding that right balance.
Yeah.
So let's talk about some specific distributed architecture styles. The book covers a whole bunch, right?
It does. They talk about layered, pipeline, microkernel, service-based, event-driven, space-based, and of course microservices, which are super popular right now.
Okay, let's start with the layered architecture. That's probably the most traditional one, right?
Yes, it's the classic N-tier architecture. You've got separate layers for presentation, business logic, data access, and so on. Its structure often mirrors how many organizations are structured, which is why it's been widely adopted.
But, like any approach, it must have its downsides. What are some of the challenges with a layered architecture?
As systems grow, layered architectures can become really tough to maintain, test, and deploy. They can also become less scalable and flexible, especially as those business requirements get more complex. And they can lead to something the book calls the architecture sinkhole anti-pattern.
A sinkhole? What's that?
Imagine a request comes in and it has to go through all those layers, but nothing really happens at each level.
Ah,
It just gets passed along like, a bureaucratic nightmare where a form gets shuffled from desk to desk.
oh, I see what you mean. So it's all process and no progress.
Yeah.
That's got to slow things down.
Exactly. It adds unnecessary overhead and can impact performance. If a lot of your requests are just sinkholes, it might be a sign that the layered architecture just isn't the right fit anymore.
That makes sense. So let's explore some alternatives, starting with the pipeline architecture. How does that work?
A pipeline architecture is great for systems that process data sequentially, like an assembly line. Each step performs a specific transformation on the data as it moves through.
So if I'm building a system to process online orders, each step in the pipeline could handle a specific stage of the order fulfillment process.
Precisely. One stage validates the order, another processes the payment, and another handles the shipping. This modular approach makes it easy to modify or even replace those individual stages without messing with the rest of the pipeline.
So if I need to add a new payment method,
Yeah.
I can just plug in a new stage without reworking the whole system. Sounds efficient.
It is. But like with anything, there are trade-offs. Pipelines can be less flexible when dealing with complex workflows or branching logic. If your process isn't strictly linear, a pipeline might not be the best fit.
Okay, I see. So let's move on to another style, the microkernel architecture. What's that all about?
The microkernel is all about extensibility and adaptability. It's got a core system that handles the basic functions, and then you have plug-in components that extend those capabilities.
Okay, so it's like a central brain with specialized modules that can be added or removed.
Exactly. Think of a platform for analyzing different electronic devices. The core handles the basic analysis, while plugins provide the logic specific to each device.
So if a new type of device comes out, you don't have to rewrite the whole system, just create a new plugin.
Exactly. It's a great way to build a system that can evolve over time. That flexibility is one of its strengths. Plus, it promotes isolation between those plugins, making the system more robust.
But managing all those plugins, that's got to add complexity, right?
It does.
Yeah.
Maintaining a plugin ecosystem, especially as it grows, can be tricky. And communication between the core and the plugins can sometimes introduce some performance overhead.
Trade-offs again, huh? Okay, how about service-based architecture? How does that differ?
Service-based architecture, or SBA, is where we really step into distributed territory. You break down an application into a set of larger independent services that communicate over a network.
So instead of having all the functions lumped together, you split them into distinct services, each with a specific role.
Exactly. Each service focuses on a particular domain, like user management or product catalog. And these services are typically deployed independently, which helps with scalability and fault tolerance.
So if one service crashes, the others can hopefully keep running. That's definitely a plus.
It is. And each service can be developed and deployed independently, letting teams work more autonomously and potentially speeding up development.
But I imagine communicating over a network comes with new challenges, right? Network reliability and security become big concerns.
Absolutely. You also have to carefully design the boundaries between those services, deciding what goes where. Getting the right level of granularity is key.
So if the services are too small, you end up with a lot of back and forth communication.
Right.
And if they're too big, you lose those benefits of breaking things down in the first place.
You got it. It's about finding that sweet spot.
This is getting intricate. What about the event-driven architecture? How does that one work?
Event-driven architecture is all about reacting to things that happen within the system. Think of it like a chain reaction. One component does something that triggers an event, and other components react. It's asynchronous, meaning they don't have to wait for each other to finish their tasks.
So if I'm building a stock trading platform, a new order could be an event, and different components could react by updating the order book, executing the trade, and letting the user know.
Perfect example. This asynchronous nature can make the system more responsive and scalable because those components aren't blocking each other. But, as always, there are challenges.
I bet. Managing that flow of events and making sure they happen in the right order sounds complex. What if there's an error somewhere?
You're right, those are big considerations. You need to think carefully about handling errors and avoiding cascading failures, where one error triggers a chain reaction through the system.
Okay, this is all getting pretty complex. What about the space-based architecture? It sounds like something out of science fiction.
Space-based architecture is designed for systems that need to be highly scalable and available, especially those dealing with massive amounts of data. It uses a concept called tuple space, which is like a shared memory area where components can store and retrieve data.
So instead of relying on a central database as a bottleneck, components can talk to each other and share information through this shared space.
Exactly. This can dramatically improve performance and scalability, especially when you're dealing with huge data sets. But, managing data consistency in this kind of distributed environment, that's a challenge.
Right, because you have to make sure the components aren't stepping on each other's toes, creating conflicts, or overwriting data.
Precisely. It takes careful design and coordination to avoid corrupting data and keep everything in sync.
Okay, and finally, this style that's gotten so much buzz lately, microservices.
Yeah.
Microservices are basically service-based architecture, but taken to the extreme. Instead of a few large services, you break the system down into dozens, even hundreds of tiny services.
So each microservice is like a mini application focusing on one very specific business capability.
Exactly. And they communicate over a network, usually using lightweight protocols like REST APIs or message queues.
This sounds amazingly flexible, but I imagine managing all those tiny independent services could be overwhelming.
It definitely adds complexity. You need robust tools and practices for things like monitoring, logging, and tracing requests across services. And testing and debugging become much harder in a distributed environment where a single action might touch multiple services.
So microservices are powerful, but come with a whole new set of challenges. Seems like there's always a trade-off.
There is, and that's why the book really stresses the importance of careful analysis and understanding those trade-offs before jumping headfirst into any architecture style. Pick the one that best suits your needs and constraints.
Speaking of constraints, we've mentioned risk assessment a few times. How do architects analyze and mitigate risks in software architecture?
They introduced the concept of a risk matrix, which is a tool to assess risks based on how likely they are and how big their impact could be. It helps quantify those risks so you can prioritize your efforts.
So if a risk is a big deal but not very likely, it might not be as urgent as something less serious but much more likely to happen.
Exactly. It's about focusing on the most critical risks. And to find and address those risks before they become problems, they recommend this collaborative approach called risk storming.
Risk storming. Sounds intense.
It basically means getting everyone involved, developers, testers, business analysts, even end users, and brainstorming those potential risks together. Then you talk about strategies to mitigate them.
So tap into the collective knowledge and experience of the team to find potential problems before they happen.
Precisely. They use a hypothetical nurse diagnostic system as an example. It shows how thinking about risks from different angles can help you uncover potential issues you might have missed otherwise.
I like this. It's like they're giving us a toolbox full of practical techniques for navigating the complexities of software architecture.
They are, and they don't just focus on the technical stuff. They also dedicate a good chunk of the book to the importance of soft skills, especially communication and presentation.
Right, because even the best architectural design is useless if you can't get other people to understand it.
Exactly. They say that architects need to be great storytellers, using clear diagrams and engaging presentations to bring their ideas to life.
So it's not just about scribbling boxes and lines on a whiteboard. It's about crafting a compelling narrative.
You got it. And they give some really practical advice on how to do that, like understanding the psychology of presentations, using visual cues well, and even manipulating time to keep people interested.
This has been so helpful. We've gone from the basic principles of software architecture to the different styles, the importance of risk assessment, and even the power of communication.
We have. It's clear that software architecture is multifaceted. It takes technical expertise, strategic thinking, and those strong communication skills. And, it's not static. It's constantly evolving.
Which brings us back to the idea of continuous learning and staying ahead of the curve. They talk about architects needing to develop a personal technology radar, right?
They do, and that's what we'll explore next. It's about keeping track of industry trends and knowing which technologies are worth exploring.
Awesome. So for you, our listener, stick with us as we dive into the strategies for staying ahead of the game in this ever-changing world of software architecture.
So building a personal technology radar, it's crucial, for staying relevant in this field. It's constantly changing, right?
Yeah, it sounds like a powerful tool, but where do you even start with something like that?
The authors lay out a really practical framework. You start by identifying the technologies and trends that are relevant to what you do and what interests you.
Okay, so let's say I'm working on cloud-native applications. I might focus on things like containerization, serverless computing, and of course, microservices, right?
Exactly. Then you categorize those technologies based on how mature they are and their potential impact. The book actually uses the ThoughtWorks technology radar as a model. It puts technologies into these 4 rings: adopt, trial, assess, and hold.
So adopt would be for things that are like well-established and ready for prime time, while hold would be for things that are either, I don't know, too risky or just not mature enough yet.
Precisely. And they emphasize that your radar shouldn't be static. It has to be a living document, always evolving as you learn and explore new tech.
I like that. So it's like a personalized roadmap for navigating the technology landscape.
That's a great way to put it. It's not about, being an expert on everything, but about knowing what's out there and making those smart decisions about where you invest your time and energy.
Makes sense.
And they also emphasize going beyond just reading about stuff. You've got to get hands-on, experiment, and build things.
So like attend workshops, play with frameworks, maybe you contribute to some open source projects, things like that.
Exactly. You've got to get your hands dirty and see how it all works in the real world.
That makes sense. Theory is important, but actually doing it, that's invaluable, especially in a field as fast-moving as this one. Speaking of experience, the book also dives into soft skills, something we touched on earlier.
Oh, yeah. They've got a whole chapter dedicated to making teams effective, and it's full of great insights. They talk about elastic leadership, the ability to adjust your leadership style depending on the team's needs and the project.
So sometimes you need to be more directive, like giving clear instructions, while other times you need to be more hands-off.
Right.
Letting the team make their own choices.
Exactly. And they have a framework for figuring out how mature the team is and deciding on the right leadership approach. They also stress the importance of trust and psychological safety within the team.
I can see that. People take more risks and innovate more when they feel supported, right?
Absolutely. And they offer some practical tips for building that trust. Things like active listening, showing empathy, and celebrating those wins. Oh, and they also recommend using checklists, which might seem simple, but they can be really powerful.
Checklists. I thought those were just for pilots or surgeons. How do they apply to software development?
Well, they can help ensure consistency and reduce the risk of making mistakes, especially in complex systems.
Okay.
Think about deploying a new release. You could have a checklist that covers every step, from code review to testing to monitoring.
Ah, right. When there are so many moving parts, it's easy to miss something. A checklist can be that safety net.
Exactly. Checklists are also helpful for onboarding new people to the team. They give a clear overview of the processes, helping new hires get up to speed quickly.
That's a great point. It's about having that discipline and attention to detail, which is essential for building high-quality software.
Absolutely. And speaking of quality, the book really stresses clear and consistent communication, especially when it comes to design principles. They argue that those principles should be well documented, easy to find, and actively used by the team.
So it's not enough to just write them down and stick them on a wiki page somewhere. You have to actually make them part of the development process.
Precisely. The principles need to guide those decisions, influence the design choices, and be a shared language for the team.
So everyone's on the same page and working toward the same goal. And it leads to more consistent, more maintainable code, too.
Exactly. They also give some great advice on negotiation, a crucial skill for architects.
I bet.
You often have to negotiate with stakeholders who may have different priorities, different levels of technical understanding, or even completely conflicting goals.
Right, right. It must be a balancing act to, juggle business needs and technical constraints while trying to keep everyone happy.
It is, and they offer some tips for making those negotiations successful, like justifying your decisions, using the divide and conquer strategy, and even turning demands into favors.
Turning demands into favors. What does that even mean?
Instead of telling a developer, you need to have this feature done by next week, you could say, hey, I could really use your help with this feature. It's important for the project, and, you're the best person for this.
Ah, so you appeal to their sense of ownership and make them feel like they're part of the solution, not just following orders.
Exactly. It's about building those relationships, getting everyone excited about the project, and ultimately getting everyone to buy into the architectural vision.
Makes sense. It's like leading through influence, not authority. And, they also talk about being a servant leader, which fits right in with that collaborative approach.
Absolutely. Servant leadership is about putting the team first, empowering them, and clearing the way so they can do their best work.
It reminds me of the idea of the architect as the keeper of the big picture. They have to see the whole forest, making sure everyone's moving in the right direction.
Precisely. It's about leading by example, mentoring others, and fostering that culture of continuous learning.
This has been so insightful. We've explored all these principles, practices, and soft skills that are essential for being a successful software architect.
I agree. The book is packed with practical advice and real-world examples.
And for our listeners, we hope this deep dive has given you a deeper understanding of this multifaceted world of software architecture.
Remember, being a software architect is an ongoing journey. It's about staying curious, embracing challenges, and always striving to improve your craft.
And as we move into the final part of this deep dive, let's circle back to some of the key points from the book and talk about how to put them into practice. Stay with us. All right, so we've covered a ton in this deep dive, from how software architecture is defined and keeps changing to that whole engineering mindset. But if we had to, boil it all down, what are the big takeaways for our listeners?
I think it really comes down to one core principle. It kind of underpins everything else in the book. They call it the first law of software architecture. Everything is a trade-off.
Oh, yeah, I remember that line. Seems simple, but I bet it's, a big deal when you're actually building systems.
It totally is. It means there's no magic bullet, no one perfect architecture that solves all your problems.
Right.
You're always weighing things, cost versus performance, flexibility versus security, and, making choices based on what the project actually needs.
So an architect's job isn't finding the right answer, it's finding the best solution given what they have to work with.
Exactly. And that's where that engineering mindset we talked about comes in. It's about approaching those decisions with data and analysis, not just your gut feeling.
Not just going with whatever's trendy, right?
Right. It's about thinking about those inamilities, evaluating fitness functions, doing risk assessments, and making informed choices.
And they give us so many techniques to help with that. We talked about ADRs, risk storming, documenting design principles.
Yeah. Exactly. Those tools add rigor to the process. But we have to remember, architecture isn't a one-time thing. It's like an ongoing process of evaluation, adapting to changes, refining things.
So you're constantly revisiting decisions, adjusting to new requirements, incorporating new technologies.
Right. This field never stands still. A good architect has to be able to adapt, to kind of roll with those changes.
Speaking of adapting, one thing that stuck with me was how much they emphasized soft skills, communication, and negotiation especially.
Oh, absolutely. Those are critical. Architects have to communicate their ideas to so many different people, developers, executives, and they often have to negotiate when people have different priorities.
So it's not enough to just be a tech genius. You've got to be a good communicator, a diplomat, a leader.
Couldn't agree more. And the book has some fantastic advice on how to develop those skills.
One thing that I remember was that divide and conquer tactic for negotiation.
Oh, that's a great one. Instead of trying to solve this huge complex problem all at once, you break it down into smaller, more manageable chunks.
So let's say a stakeholder wants the whole system to be super available, like no downtime ever. You might try to figure out if every part actually needs that level of, I don't know, robustness.
Exactly. By breaking the problem down, you can often find areas where you can compromise. You get a solution that meets the most critical needs without, going overboard and over-engineering everything.
And they also talk about framing those requests as favors, making it collaborative, not just orders.
Right. Building relationships, motivating people, making them feel like they own the solution.
Oh, and another point they made about presentations was the power of invisibility.
Oh, yeah. That's a great way to keep people engaged. Instead of showing this massive, complicated diagram all at once, you reveal things slowly, piece by piece.
Kind of like a magician, right? Building up the suspense.
Exactly. It's storytelling, creating a narrative that grabs people and helps them get what you're trying to do.
And along those lines, they talked about using metaphors and analogies to explain those complex technical ideas so they're easier to grasp.
Yeah, analogies are super helpful for explaining abstract things, especially to people who aren't, deep in the technical weeds.
This has been fantastic. I feel like I have a much better understanding now of what it really means to be a software architect.
It's definitely challenging, but, it's so rewarding. It's that mix of technical skills, strategy, and those all-important soft skills.
And it's never boring, that's for sure.
Mm.
Always learning, adapting, trying to build the best systems you can.
Absolutely.
Well, for everyone listening, we hope this deep dive into fundamentals of software architecture has given you some great insights and maybe even inspired you to learn more.
Remember, being a software architect is a journey. It's an ongoing process of challenges, learning, and, the satisfaction of building great solutions.
Thanks for joining us on this deep dive.